Hello students, today we're going to look at 9.7 in Algebra, which is factoring special products. Now if you'll remember a couple of, probably several lessons ago, we did some shortcuts and we learned how to do some shortcuts for some of our multiplying binomials. Well, now we're going to take those shortcuts and work backwards. Because these shortcuts that we learned back then are this, and 9.3 if I'm not mistaken, are the same shortcuts for 9.7 factoring. So the first one would be factoring the difference of squares. So we'll put factor difference of squares.
Michaela Herndon, please report to parent room pickup.
So when we factor difference of squares, we are given the difference of two squares. For example, y squared minus 9. First of all, it's a difference, and both of these are perfect squares. Y squared is a perfect square and the square root is y. 9 is a perfect square and the square root is 3. So to factor this, I'm still going to have two binomials, but you'll remember from that shortcut, it's going to be y plus 3 and y minus 3. If I did y plus 3 times y minus 3, if you remember correctly, that OI becomes negative 3 and positive 3, which is 0, so there's really no b. It's just y squared minus 9. So when I factor y squared minus 9, it's the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. Let's look at another example just for fun. 64c squared minus 16. 64c squared minus 16. I have a difference and I have two perfect squares. So square root of the first one would be 8c plus 4 and 8c minus 4, which is kind of hanging off the TV, but I'll let you trust that you can see that. Square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. That's a shortcut for factoring the differences of squares. Sometimes with the difference of squares, you have to factor out a greatest common factor first. So my greatest common factor between 12 and negative 48 would be 3. So 3 would be 4 minus 16m squared. Now I have 4 minus 16m squared, which actually is a difference of squares. So I bring the 3 down. The square root of 4 is 2 plus 4m times the quantity of 2 minus 4m, and now I'm done. I don't have to do anything else, but I factored my difference of squares to 2 plus 4m times quantity of 2 minus 4m. The next special product we're going to look at is the perfect square trinomial. Now I know it's a perfect square trinomial if the square root of the first term times the square root of the last term times 2 equals b. I'll say that again. The square root of my first term times the square root of my last term times 2 equals b. Now let's look at an example of that. If I have a squared plus 6a plus 9. Is this a perfect square trinomial? I take the square root of the first term, which is a, multiply it by the square root of the last term, which is 3, and multiply it by 2, and I get 3 times a times 2 is 6a. That's my middle term. So this is a perfect square trinomial. To factor a perfect square trinomial, it's just a plus 3 squared, or the square root of the first term plus the square root of the last term squared. So I have another example, 4n squared plus 20n plus 25. Does this fit our perfect square trinomial model? The square root of 4n squared would be 2n times the square root of 25 would be 5 times 2. 2 times 5 is 10, times 2 is 20n. It is 20n, so this is a perfect square trinomial. So in order to factor that, I just use the square root of the first term plus the square root of the last term squared, and then I'm done. Now, if you don't like to use this model, you don't have to. You can factor it just the way we normally factor, by finding two factors of each one of these and coming up with two binomials. This is just a shortcut if you want to test out the model to see if this is a perfect square trinomial. Even with trinomials, sometimes you have to factor out the greatest common factor. So I'm going to find the greatest common factor between -3, 36, and -108. I want to make sure to factor out that negative since I have a leading coefficient that's a negative. So my greatest common factor is -3. -3y squared divided by -3 is y squared. 36 divided by -3 is -12y. And 108, -108, divided by 3 is positive 34? No, 36. Okay? Close the parentheses. Positive 36. Now, let's look at just the trinomial. Is it a perfect square trinomial? The square root of y squared is y. The square root of 36 is 6. That means 6 times y is 6y times 2 is 12y. But hold the phone. I've got a negative here. So that means this factor's got to be -6. So y times -6 is -6 times 2 is -12y. So yes, it is a perfect square trinomial. So to factor that, I bring my -3 down, and then it's y minus 6 squared. So your practice problems for this weekend are here. There are 4 of them. Number 1 is 25y squared minus 64. Factor that out. Number 2 is -3m squared plus 48r squared. Factor that. Hint, you might have a greatest common factor. Number 3 is w squared minus 14w plus 49. And then number 4 is x squared plus 2/3 x plus 1/9 equals 0. Don't get tripped out over the fractions. Think about the square root of 1/9. Factor it out, set up our equations, and tell me what x equals. Please take a picture of your practice problems and submit it through Edmodo before you get to class on Monday.